Hey, what's up, guys? This is Chung here. And so tonight I want to talk about another LeetCode problem here. Number 658. Find k closest element. All right. So you're given like a sorted array, right? Keep in mind it's a sorted array, and then you're given two integers, k and x, where is the x is the target value here, and you need to find the closest case numbers, right? Closest case numbers uh, to this number three here, right? For example, this one, it's a 3, 4, 1, 2, right? So basically, in total, you need to get four elements, and then who's like basically the absolute value, the difference between this target is the smallest, right? And you only need to get four, up to four elements. So every time when you see a sorted array here, and they ask you to find some like method, some positions or elements into a sorted array, you should always try to use binary search. Okay, so in this case, okay, so what we're trying to search, right? So with the binary search again, we need to get a left and a right uh, boundaries, right? So what's the left? Left is okay. So first, so what are we searching here? So basically, we're searching the starting point, right? We're searching the starting point of this subarray, right? Basically, as you can see, so our result has to be a subarray here, right? So and our binary search will be searching the starting point, the I, right? Let's say we have a subarray here, uh, I to I plus k, uh, right? So that's the I. Mm, yeah. So assuming we have this subarray, right? We have this element from this case length, and our binary search is to search this I here. So what's the I? What's the starting point? And once we have the starting point, we can just simply return I to I plus k, right? And one thing to notice that the return result, I mean, it's always like a continuous subarray, right? Since we're going to get the closest, comparing uh, closest array to 3. So and it's a sorted array, so there has to be a continuous subarray. So let's see, then what's the starting point? The starting point is 0, right? How about the end point? The end point will be like n minus k, right? Because since we're searching the I, so we have to make sure this endpoint, starting here, we have enough, we have at least case elements, right? And then how do we search, right? So once we have a middle point here, so once we have a middle point, right? And we compare it with x, right? So let's say we have x here, right? So the x is the range, right? So we have x here. Uh, okay, so um, let's say the middle point, right? Let's say the middle point is somewhere here, and let's see what I'm trying to say here. Okay, so let's say we have the middle point is basically our starting point, right? Let's say, for example, our starting point is here. Let's say this is a line here, right? And this is the x. Let's say our middle point, the starting point, is somewhere here. That's the middle point here, right? So how can we know if we need to move this middle point either to the left or to the right, right? So this is the middle point, and here's the middle plus k, right? Let's say x is right in the middle somewhere, right? And then we can just simply check, right? So how can we know? We just compare the distance between the x and the middle and the middle plus k and x, right? So if this basically if this side is bigger, then we know, okay, we want to move our middle point to the left, right? And if this side is bigger, then we know, okay, we need to move the middle point to the right. So yeah, basically that's our basic binary search strategy here. And let me try to code it. So basically the left is 0 and the right is to equal to the uh, length of the array minus k, right? And then while left is smaller than right, okay. And then we do a middle, right? And uh, if right, if x minus array dot middle is greater, right? If it's greater than the array dot middle plus k minus x, right? And then we know the left side is bigger, right? The left side is bigger, which means we need to move this our current search to the right side, which means the left gonna be equal to the middle uh, plus one, right? Else, else we do a right equals to middle, right? Why we're doing a middle? Because we're doing like a greater or smaller than a greater than here, right? So if this thing is the same, if this arrange is the same, then we know, okay, this middle is our might be our result, right? So that's why we keep this right to the as the middle here. And so uh, and then in the end we can simply just return what the array from left, right, to left plus k, right? Run it. Cool. So yeah, I think the basic idea here is the just to use a sliding windows. You know, basically if the sliding windows, we 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 check where should this sliding windows move to, and we compare with the distance between those two, like the left's boundaries and the right's boundaries of this sliding windows, right? And then we try to find we're trying to find like a position where the x to the have the same distance to the left and the right of the sliding window, right? And then we know, okay, this is the place we need, right? Okay, cool. I think that's it for this question. Yeah. Okay, thanks so much for watching the videos and see you guys soon. Bye bye.